Hello and welcome. Today I'm going to talk about container in Azure. And this time I'm going to show you everything in Whiteboard. This is to clear up some of the basic concepts of container and how it can work in Azure. I have created many demos related to container and Azure in my YouTube channel. So if you want to see a working demo, you can always visit them. But this time I want to step back and try to explain in this Microsoft Whiteboard what really container means, what application means, what exactly we do in the container, and how you can host them in Azure. So let's start. So before we dive deeper into container, let's understand the application. So whether it is a virtual machine or a container, you end up running an application. And that application is built by us. So we write code. So let's assume that you have got an application file which contains a couple of lines of code, which is a type of application which runs on a machine. Now, this could be an HTTP web application, which is a common kind of application, or it could be a simple script which might run in a timely manner. Now, if it is a web-based application, you will have an HTTP endpoint through which you will call this web application like localhost port 8080, and then you see that either in the browser, which is your desktop browser, or if you're running in a headless Linux machine, you can use curl command to run them, right? So that's the application. Now, when I write an application, this is the code where you define the instruction of your application. Now, along with the code, once this code is kind of ready, written against some runtime, think of it as your boundary of code. So it could be JavaScript, it could be Python, it could be Go, it could be .NET. So any of these runtime or libraries will help you build that application. So depending on which runtime you are using, so let's say you are using JavaScript, you will have to build that application for that runtime. So there are set up steps you need to take to run the build for Java. And when you run these steps, you essentially do certain actions. And after that, in a typical pipeline kind of scenario, you run a test. And after the test is successful, you package them for deployment, which can then go and run in the production. So essentially, you are making a source code which you create at the beginning ready, which is number, let's say X at this step. So these are the activity we typically do through automation. And in a typical DevOps scenario, we call them CI CD, continuous integration, continuous deployment. So that's the application development lifecycle, right? Or we sometimes call as software development lifecycle. Now, in this software development lifecycle, there are challenges with this kind of approach. One is if you consider the JavaScript as a runtime, it has got many versions. So if you write the JavaScript and use, let's say, version 1.14, and if your production machine does have something like 1.12, this code might not work, right? Or you might be running something like a higher version like 1.15, then some of the old stuff which is getting used may or may not or work. So that's the discrepancy between the machine with runtime and libraries a developer uses versus the machine where the code will be deployed. Now, typically, these prod servers are highly secure and unlike developer machine where you keep on installing many stuff, you can't do that here without permission because it is all about security. Let's suppose you install something which is vulnerable library and that can open up the port and then people can start attacking. The bad actors can reach out to the server and steal your data, which is obviously not what you want in a typical production kind of environment. Now, when we talk about this, let's say we move them along, we have different approaches to run application in a scenario like server. So let's assume that this is your prod server. In this production server, what you can think of installing the runtime on top of the operating system, configure it as per the requirement, and then put the code on top of that. So this is way of like on-premises way of doing it. When you move into a little bit of a virtualized environment, you again still have the server, but on that server, you may have a VM, which is again hosting the same thing like operating system, runtime, and code. All right. Now, if you look into this kind of scenario, right, this is how most of the application runs today. And this is something which started a decade ago. So this is what we call a virtualization. It essentially means that using one single hardware, you build some, let's say, area for your application where your application can run independently. One of the things about the virtual machine is that you can have a host machine, which is basically the main machine, which can have either Windows or Linux. Let's suppose you have the Windows host machine, which is using hypervisor technology. If you have that kind of setup, and on top of that, you can install many different versions of Windows. So let's say I install Win 10, an application which may require Windows 10, I can use it. I can use Windows 2019. I can even use Red Hat Linux. I can use Ubuntu. So I am not bound by what operating system I can run in this machine. What these machines are basically doing, it is leveraging the physical RAM attached to this host. So there's a certain amount of RAM, and then it is also using certain number of CPU core, X core, and then you have a storage attached to it, which is also getting shared along with the network, etc. So what you see over here is certain amount of RAM. Now let's assume that this virtual machine has got 64 GB of RAM. If one of my application needs to have, let's say, 32 GB, I create a VM using a 32 GB RAM. From this, the remaining available RAM would be 32 GB. So my now host can have additional virtual machine within this. Now you have to remember that host also needs certain amount of RAM. So there is a bit of battle between what resource you allocate to a VM for your application versus what you left out. So it is a lot of resources, though it is not the dedicated machine, but it's a lot of resources, which essentially is a cost. So if you look from a hardware purchase perspective, it increases the cost. Cost goes up here. Okay, so you see here that this is what the challenge with the virtual machine is. Now with this concept of virtual machine, we are still running a lot of workload, so it's not bad. What we started now doing a little differently is that instead of virtual machine, we kind of try to optimize the way of working. So we say that we have an operating system called Linux. In that, or Windows, either of them, in that you run something container runtime. So that's where you can install within a virtual machine also. So you basically install an operating system and then install the container runtime. So this is the step number one. In this step number two, you use the container runtime. And then container runtime has a kernel, operating system kernel, which is being used by a little smaller piece of thing we call as container, which essentially is your application hosting platform. Now, one of the things which you cannot do over here is that you cannot, let's say, have an operating system using Linux and then have Windows container. So you have to decide what kind of container you want to run here based on which you choose that operating system. So if you need to host Windows container, you need Windows virtual machine. If you need to host Linux container, you need Linux virtual machine. That's the only difference. But you can have more such container because the size of the container is really small. So when you talk about container, they don't have, let's say, huge amount of RAM. They definitely need certain amount of RAM, but not as huge as a virtual machine may need, because virtual machine does really require a lot of RAM and CPU to run the operating system. Here we are not running any operating system. So there is no OS running over here. So we are just not using it. Now, after that, what you essentially need to do is that you need to think about how this application will be deployed over here. Now, imagine that you have application running in a machine where it is really hybrid. So you can have one container hosting a Java application, which essentially means that you got a JS application, and then you may have, let's say, a net core application, which can run in Linux. You can have something here as a Golang application. You can even have Python application. Now, even in the world of Python, you can have different version of Python application. So let's say Python 4, and this is Python 3. So imagine that your operating system kernel, which is basically serving these containers, are providing the basics of our operating system, but the runtime, etc., needs to be configured. Now, if you start deploying these into, let's say, the virtual machine which you are using. So what you essentially can have a conflict. So I mean you have a problem. So instead of that, we say that you do not need anything in that operating system, the main operating system. Rather, you configure that container which contains your code. So if you remember the first piece of thing we did, right? We had a small piece of code, and then that code contained few lines, which is what we need to run in this container. Assume that it's a Python code, and then there are set of instruction to compile this code, and it uses certain runtime, so etc. So what it then do is that we create a instruction manual along with the code. So if you start looking into the application which you have built, you need a base operating system, base image we can call it, which basically tells a specific version of a Linux image. So let's say it is an Ubuntu image. And then you install the runtime in that image. Maybe the image can contain the runtime, or you can separately install the runtime. Then you copy the code from the local machine or the development machine, and then you run the build and you run the test. Then you just run the application through the command. So these are all instruction. So each line is an instruction. When you are done with this is probably a few KB of size, this file. It'll do step-by-step activity. It'll download something from somewhere. We'll talk about it. It'll go inside that something from somewhere and install the runtime. If it is, let's say, npm, so you just npm install, and it'll install everything which is there in the source code configuration. It will just compile the code, it'll run the code, and it will just test the code, and then it will run the code, right? So that's what we call a Docker file. It's a standard name, right? So Docker file. It just doesn't really have any extension. You can give any name to Docker file. Just you need to run them as part of the build process. That file name needs to be provided. So convention is you provide something called Docker file where D is capital. But there is no harm having the file name like that. You can have Dockerfile 1, my Dockerfile, or XYZ Dockerfile, or XYZ instruction, hello world, anything. But the internal instruction should follow the standard of the Docker file. And then once you have that, you can actually, what you get is something we call an image, okay, which contains a couple of things. The compiled code, that's after you run the build, runtime. So if you're using specific version, specific library, that will be part of that runtime and library. And then you have that run command. Okay, so that's where what the Docker file will create as an output. So you can see that you're getting some MB of output depending on how big that base image is. It could grow to GB also, so depending on what that size is, but you get something called an image. We call this as a container image. So the container image essentially is an independent entity which you can host anywhere and run the application exactly as is. You don't have to break your head about like what runtime my developer needs, my application needs, etc. You just simply go ahead and run this code anywhere and everywhere, which supports any standard container runtime. So this is sometimes known as cloud native because it doesn't really tie to any specific cloud provider or any specific thing. So it can run on premises. This code can run on premises. It can run on cloud. It can run on edge. It can run on devices. Wherever you can run container runtime. So again, if it is built using Linux base image, it has to run on a Linux container runtime machine which runs in Linux container. So this is what it looks like at the end of the day, that you have got your container ready for the deployment. So your CI/CD is not just building that application, but it also building a container image which hosts that application code and the executables, etc., inside that image, ready for deployment. In the sense, like you just copy that image and it will start running. Now you need definitely a platform. A platform could be a virtual machine. So let's take a simple step. So let's assume that this is my VM. Either it could be an Azure, it could be on premises, it could be your hypervisor machine also. Now this is hosting a kernel, and on top of that, my container is running. So I can host the container. I don't have to make any changes to my container image if I want to run it on a VM. Now this requires additional maintenance overhead because it essentially needs you to install the runtime, make sure it's updated, network, safety, security, resiliency, high availability, etc. All of them are part and parcel of the management. So it is what we call as IaaS, infrastructure as a service, which needs management, more management. Instead of that, we say that, so this can be done on either Azure or on premises. So yeah, I'm just highlighting that fact. But if you think about like somebody is owning that virtual machine piece, right? That VM piece is owned by somebody, operating system is being installed by somebody, patching is done by somebody, networking is configured by somebody, storage is managed by somebody, backup is done by somebody with a service level agreement which ensures that high availability of the virtual machine. I can then peacefully run as many containers as I want in this environment without really bothering about the management. So there is zero management here. So there is no management which is required. And that's what in Azure we offer as a service called Azure Container Instance, ACI. Now this is a PaaS service, which essentially means that you own the code, we own the infrastructure, right? Now we have been talking about this image, the container image. So if you talk about container image, that has the source code and runtime and everything, it has to live somewhere. And that place is sort of like a repository, we call it, ready to get things downloaded and installed. So if you think about this repository, it is it is kind of like a place where you keep adding these container images, and we call it as container registry. So the container registry is the list of container images which you can download from, right? It can be both public or private, depending on the kind of application you are working with. You can choose to define that. You can host it on premises. You can use already available container images, etc. available. So already available container public container images are like Docker Hub, which you can go ahead and create a new login and then keep putting your container images. In the free version, it allows one private and remaining all public. You can pay some money and then make it a fully private container registry. Like this, in Azure also, we have something called Azure Container Registry. So if you think about Azure Container Registry, right, it basically is a service provided to you where you can upload and download images. So the images can be uploaded from your dev box or DevOps machines and then downloaded to your production to run as an application. Now, this is known as ACR. You often will encounter this name. Now, that's not a container hosting platform. It is just the repository of your container images, which can be leveraged or used anywhere you wish to, right? So it's sort of like a place for you to, like NPM or NuGet, where you basically get all the libraries. Now, coming to that next part is where you have in a typical enterprise scenario where you have, let's say, different application or different type of thing working together as a single application. So you have one application, you have application, 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 and then you have got database, which is basically this application talks to this database. They also talk to this database. This database sends here, this database sends here, it talks here, it talks here, it goes here, it goes here. It also can come here, it can come to the database. We have done that already. It can also come here. So there's a mesh of things happening, right? So you basically can say that's a C1, C2, C3, C4. These are all four container-based application, including a database, probably running inside a container. You never know. But this is a very complex deployment. Now, Azure Container Instance is good that it does not need you to take any pain of maintaining, managing the container runtime. But when you have this complexity of, let's say, many container using, then can you do a copy here? Maybe you want to run C3 in 3 instances so that the load is distributed, right? Sort of like scaling individual component of your application depending on the load of that part is kind of very difficult to maintain and manage in Azure Container Instance. And to achieve that, what you need is a solid container orchestration mechanism. And that's what the de facto standard today is Kubernetes. So the Kubernetes is a standard runtime. Sometimes it is known as K8S because there are 8 characters in between K and S that makes it a name called K8S. So you can see that this is basically is a set of things which you are not going to do or understand in a detailed manner, but it gives you places to host your container and it's fully managed. Okay, so you don't have to install, maintain, and manage these things over here, right? So you host your C1 here, C2 here. It takes care where to host because depending on the size, if you need multiple copies of C3, you might need C4 here, C4 here, C4 can come here. So like that, you have got multiple application running. And that is available in Azure as Azure Kubernetes Service. And that is known as AKS. So this is also another container hosting platform. And there are a bit of abstractions available in other services, like, for example, if I go into this documentation, official documentation, which talks about what are the other services which uses this container, right? So you can see that it has got something like AKS, which is a Kubernetes runtime available. You have the Azure Red Hat OpenShift container available. You get something like Azure Container Apps, which can host your static apps and all this kind of apps in a much more easy way. You have Azure Functions, which you can host in a container. You have got a web application for container. You have Service Fabric, which you can run inside a container. And we talked about the container instances and container registry. So there are other highly abstracted services available which can allow you to build the container thing